Great. So like I said, we're going to start off by going over some of the NRP offered services, namely JupyterHub and Coder. And we're also going to show you how to interact with the uh, LLMs that NRP offers. We'll be doing that with JupyterHub. If you recall, if you joined one of the basic tracks either a couple days ago or last week, we were using JupyterHub as well, but this was more as a tool to kind of keep everyone on the same kind of operating system so that it would be easier for the instruction. Today we're going to show you how to actually use the JupyterHub instance that we deploy as a normal user. So let's see. First thing that I will share with you, kind of as a refresh, is since we're going to be using LLMs, one of the requirements to be able to use an LLM on NRP is to generate an API access token. This can be done by if you're already a member of a namespace that has the LLM flag enabled, then you could do this already. But for the purpose of the training, I'll create a new namespace, and then we'll create a token that we'll share for the tutorial itself. Oops, and this will be sort of a refresher for people who saw the beginner track, because I'll show you kind of how to create a namespace. So this is the namespace tree, and since there were a few people that weren't able to join the beginner track, I'll just briefly say that NRP is a Kubernetes cluster. So it's a nationwide cluster. Let me open the dashboard. So this dashboard shows the different NRP sites. So these are computing nodes essentially. So it's nationwide, covering all of the US, but there are also some international locations in Europe, Asia, and South America. So it's quite a large cluster, and it provides compute resources to higher education needs, such as uh, research projects or instruction projects. So a good chunk of people on NRP will use it to do their academic research. Another chunk of people will use it to instruct the courses that they're teaching. And this is, both of these can be done either by interacting with Kubernetes or a lot of people tend to go the Jupyter Hub route. So they'll create a bespoke Jupyter Hub deployment that they'll use for their class or for their project, and they'll work from there. Um, so you can see some info here. So there's just under 500 compute nodes in the cluster, well over 1,400 GPUs and over 31,000 CPU cores. These are uh, constantly growing. So NRP works as kind of on the potluck model. Basically, if an institute or PI is interested in joining the cluster, they could come with their compute resources, and we could host them on NRP. We'll take care of the maintaining these resources, keeping them up to date. And then the PI or institution just needs to take care of the actual physical housing of their compute resources. Um, and that's what happens for the majority of the cluster. Some of these nodes are part of a initial grant to start the cluster, but other than that, there's a large portion that have been donated. Um, and going back to why I mentioned Kubernetes, is the basic model of Kubernetes is that projects are constrained within a namespace. So um, a group or a project will create a namespace. I'll just go to my namespaces to give you an idea. This is the overview picture of the all of NRP's namespaces. If you were to go to this link, you would see any namespace that you belong to. Um, you won't necessarily see this entire tree like me, just because as admin, I'm part of every namespace. But the basic way that this is organized is that at the root of this tree is NRP. And then the branches are typically individual universities. So here you see Berkeley, you see UC Davis, etc. And then let's go to UCSD, since that's where I am at. You see UCSD, and then branches of these institutes or universities are individual PIs or like sysadmins that will be using NRP. So let me find. Oh, okay. So I'm under NRP Dev, and then here's myself, DDS. Um, so this is a Kubernetes namespace. So in the beginner track, I mentioned that the items in red are not necessarily namespaces; they're just groups to organize things better. And then we have some other different colors, which you could review the previous video to know, or the previous material to know what they are. But the most relevant right now is we're going to create a new namespace that has the LLM flag. I already have this LLM tutorial. I'll create a new one so that we could see. Okay, so here. This is this is the DDS namespace, and I want to create a new group under this namespace just for LLM. So what I'll do is I'll scroll down to um, create subgroup. Now I don't need this to be a Kubernetes namespace, so I'll remove that flag. But I will want LLM group access, so I'll include this. And then I'll give it a unique name. So something I was mentioning before is that although the tree on this page is nicely organized in this branching structure that looks like it has this nesting, as DDS only lives under NRP, UCSD, NRP Dev. Um, the Kubernetes namespace DDS is actually flat. So since I'm using DDS as the name of my Kubernetes namespace, that means no other user or group can use that namespace again. So um, for Kubernetes, all namespaces need to be unique. And it doesn't matter if they're nested in this organizational tree as this. Any namespace needs to be unique. So you should always try to create unique descriptive names for your namespace. So for this one, I'll do DD as LLM, winter. Oops, and that's another thing. It's only lowercase alphanumeric letters and hyphens are allowed in the namespace. So winter 2026 should be good. Has a LLM, and I'll create. Okay, that's created. So I should, oops. Okay, if I go here, yeah, I can see it. And it's yellow. Yellow just denotes that it's a group that has the LLM flag enabled. Okay, so next, as I mentioned, we need to have a access key in order to use LLMs. So I will go to, oops, I will go to the user portal and then select LLM tokens. I'll share this also in the chat. Um, so if you go here, chances are that you'll see something similar like this. You might see some tokens that you have generated already, or you might see an option to create a new token. You could also see a message saying that you need to be a member of a namespace that includes LLM access. And that's just because of what I was discussing previously. We control LLM access through these tokens, so only namespaces that have that LLM flag enabled are able to actually get a token. So if I go to group here, I should be able to see the namespace I just made. Um, let's see, might be lagging. Might take a minute to load. Okay, I think it's just takes a moment for the new namespace to be propagated through. But it's okay. What I could do is I could use this existing one and I could create a new token. So winter 2026 training. Um, so one thing I want to mention when I create a token, so tokens are given to individual users. So when you create a token, you should create that for yourself and you should save that in a place and not share it with anyone else. The reason that we create namespaces and have these groups is that if you're managing a group and you want to provide multiple people access to LLM tokens, you can add them as members of the group. So here I'll just show you, this is the group that I just made. I'll add a user, I'll add Mohammed since he's on the chat and he's also admin. Um, go this, add. Hmm. Okay, so now this namespace just has myself and Mohammed. That means if if Mohammed was in no other namespaces, he could come to this LLM token page. He could open it, and then he should be able to see the training once it populates here. Let's see if it could. It's a little bit slow this morning. I'm not sure. Let's see if it finds the new group. Ah, okay, there's the one that I made. Okay, so yeah, Mohammed should be able to see this group after I add him here, and then I'll create a new token. Winter 2026 training. And as I mentioned, he would be able to create his own token. I would be able to make my own token. We wouldn't share these tokens, and we wouldn't be able to see each other's tokens even as admins. We would just see that they exist under this namespace. Um, so actually in that vein, I should name it properly since I'm making this token. I'm gonna give it the DD as name. Um, so then you have two options. You could create the token for general LLM access, which is what we'll do today, or you could create the token for a chat box configuration. And so Chatbox is just another app that you could use with the NRP LLMs, the chat app similar to ChatGPT. You can find more info about it on the docs, but we won't be doing that today. We'll just use a regular token. Now, as I as I was stressing just a moment ago, when I create a token, these are for personal use and they shouldn't be shared. For the purpose of the tutorial, I'm making this token and we will share it. But then as soon as we're done with the tutorial, this token will be removed and access will be you won't be able to access it anymore. So I'm sharing this in the chat now. You could save it to a notepad or something for now, and then we'll come back to it later. Important thing when you create these tokens on the webpage, you'll see this pop up. It will show you your API key or your token. And then once you close it, it'll be gone. You won't be able to see this anymore. Instead, what you'll see is this information here. It will show you the alias, what group it is in, and the token, like beginning and end characters. So you won't get the full token. Okay, I'll just pause here in case there's any questions. I'll pause the recording too. Nope, all clear. Okay. All right, sounds good. So we'll continue forward. Okay, now we'll go back to our tutorial, and what we're going to do is we're going to use our Jupyter Hub. So let me stop this because I want to show you how to log on. So if you all will navigate to this link, as mentioned in the beginner track, NRP has Jupyter Hub deployments of deployed as a service to users. There's Jupyter Hub West, which is where I'm going to work from and where the majority of people will work from. There's also Jupyter Hub East. Uh, oops, East. This is also offered, though it sometimes is used for development. So you might see some different information here if you work from East. But the majority of people work from West. So if you were to go to Jupyter Hub West, you should see this page after logging in if you haven't logged in. And this is what we call the spawner page. And basically, it's how you'll pick the resources that you want to use for your Jupyter Hub notebook that will be deployed. And you can see there's a number of options here. So you could pick a region. So if you need to select a geographical region that you need to work from, maybe you have some storage on a certain region and you want to have your notebook uh, physically located closer to that storage to avoid any delays in loading or mounting this storage. You could do this. That's a pretty common use case for people who are working with large volumes of storage at any rate. Um, there's also a picker for GPUs, so you could enter in some number of GPUs that you need. Okay, so there's a limit at 8 if you use this picker. Um, Number of cores, CPU cores, you could enter. I don't know if there's a limit on here, but you could enter many cores. And then just to comment, since the 27 cores is quite a lot, if you are um, going to request a notebook, one thing that you can do is to check the resources page to see that that there's some nodes available for you. So we went over the resources page before in the beginner track, but just to give you an idea, say like maybe we want um, 8 free, oops, greater than 8. Greater than 8 CPU, and then like greater than 8, greater than 5 gigs of memory, something like this. Or maybe I also want to make sure I have like 2 GPUs, right? So we could say um, greater than 2 GPU. So then you can see these are the results, resulting nodes. So the name column is the node. And you can see that all these nodes meet the selections that I have that I've placed. So in principle, if I were to ask for a notebook that has all these items, I should be able to land on one of these nodes, with the exception of the ones in the taint column with a value in this taint. So I see there's a question about the taints. So that it's good that you mentioned this. A taint is basically a label that we add to a node. It could be added for multiple reasons, but the main idea or the big picture for a taint is that it's a node that's not accessible to the general population of NRP users. So one reason for this is if the node is reserved. So people who donate hardware or people who are working on some kind of special event may need exclusive access to the node for a period of time. So they'll put a reservation on the node and only they can access the node. So you'll see like these 2 nodes here are reserved. And then there's another case where a node may have a problem that needs to be fixed. So here is a node, these nodes down here, they all are flagged with this issue flag of this issue taint. And that means that there's some problem with the node that we're working with some people at the data center or in operations to kind of correct. So, and if you are interested, um, you can see for the issues, if you ever want to know what's specifically wrong with the node, you can look it up. So, um, what is this one? 1545. Let's just see what that one was. Uh, sorry. Okay, let's scroll to it. 1545. So yeah, there's GPU issues on that node. So it needs to be fixed. Okay. So yeah, so be cognizant of what you're requesting. If you request something that is just way yeah, way out of line with what's available, then you will enter a problem of, not actually scheduling your notebook and you'll see an error. Or if you request resources that you don't use, that's actually against cluster policy, so you'll probably get a message from one of us. Basically, just as a general rule of thumb, the cluster policy, you should only request what you plan to use. Requesting, and then when you're done using it, you should free up those resources to the other people in the cluster because NRP is a shared resource. So it's as you saw this distribution, it's available to any higher ed group. So that includes universities and higher education um, organizations like Open Science Grid, for example. So, um, sorry, I see a question. If by mistake I request a resource which is tainted, am I going to be banned? No, because this should never happen, essentially. You cannot land on a resource that has been tainted unless you include specific instructions in your configuration file to allow this. So it's called a toleration. And these are very specific lines in your configuration file. And basically, if you're adding these lines, then it's not a mistake, and that means that you intentionally try to land on a tainted node. And you should only do that if you're given the permission to. Otherwise, then yes, we would reach out to you and ask you what's going on and correct that in the future. And then eventually, if it's a repeat occurrence, it could result in a ban. But thankfully, that's not something that should happen by mistake. So that's someone who's explicitly trying to do something that they shouldn't. Um, and if you're using our Jupyter Hub, then this shouldn't happen at all because you don't actually create a configuration file. So with Kubernetes, the way that you would interact with Kubernetes is you create a YAML file. It's a YAML file or config file that that describes what you want your Kubernetes workload to do. And then you submit that Kubernetes file or that YAML file using a Kubernetes control command line tool. So when you're working with Jupyter Hub, you don't actually have that interface, and you're just picking some options here, and then all of that will be done on the back end for you. So you don't actually have that control. But so just continuing on in this page. So for today's tutorial, I'm going to keep it simple. I'm not going to request any GPUs. Um, I guess maybe I'll do 4 cores, 8 GB of RAM. There's also FPGAs available on NRP. We don't need those for the tutorial, but they're an option to pick if you want to develop with FPGAs on JupyterHub or on the cluster in general. If you need a specific type of GPU, so some GPUs have different memory options, or are just that have different performance characteristics, you could choose from these here. But if I don't, so we're not choosing any GPUs today, so it doesn't matter. But you could also just pick any general, and it would just select a GPU, any GPU that's available. Um, and then for our Jupyter Hub, we have a number of images that can be loaded. So these will all be loaded with a Jupyter with Jupyter. But there's also different tools. So there's PyTorch, R, Julia, TensorFlow, these kind of things. We also have images that are created but in-house. So the ones labeled NRP, etc. These are some images that are created with NRP in mind. So they're organized in a way to specifically work on NRP and curated for people who use NRP. So you'll see a number of these. There's MATLAB. There's a desktop GUI. If you guys prefer to use like a desktop, you could request an image with one of these. And then finally, at the end of this image picker is architecture. So the majority of nodes on NRP are AMD 64, but there are a few that are ARM. So just remove these. Let's see. There's a maybe I missed. Maybe if I go here. Okay. Yeah, so there's 3 nodes, for example, here that use ARM 64 architecture. Okay, so for the purpose of the tutorial, um, I have 4 cores, 8 GB. That should be good. I'll work with the PyTorch image. Um, so I'll go ahead and start this server. Um, so when the server starts up, you'll see this dialog. It will tell me that it's attached a PVC. So if you were in the beginner track, a PVC is a persistent volume. Kubernetes is inherently an ephemeral kind of workspace. So typically when you do anything on Kubernetes, it will create a small instance of what you're doing called a pod. That's the smallest, most basic unit of a Kubernetes workload. And that pod will do whatever task you have configured for it in the YAML file. And then once it's done, you delete the pod, or the pod it's deleted by some controller, and then it's gone. So if you didn't save any data as part of that workflow to a PVC, then it's lost. So that's something that you should be cognizant of, especially if you're running kind of a long job, and you expect to kind of get some data or output, or you know, just in case you are running a long job that may take a while and may fail, because pods could be evicted at any time. So a node may need to undergo maintenance, or something could happen where the node shuts down. So that pod could be evicted, and there could be hours of work. So if you're not benchmarking, or if you're not benchmarking or saving progress in some way, that could be lost. So it's always good to use a PVC. And for JupyterHub, these are constructed for you by default. Everyone is given a PVC who creates the notebook for the first time on JupyterHub. It comes with 5 GB of memory. If you need more memory, all you have to do is reach out to us on the support chat, which is Matrix. Let me go to the Matrix chat since people may not have seen. Oh, there we go. I usually use the desktop version, but I'll share this here. So now the support opens, and you can see people are sending their questions to Nala support, and that's the main avenue for getting help when working with NRP. If you have questions, reach out to us on Nala support, and either myself or Mohammed or even the community can answer you. It's the quickest option you have. But a pretty common thing is somebody will exceed the 5 GB limit and will need some more space. So they will reach out, and we could do that for them. Um, okay, so continuing on. Oh, another thing to clarify. So since this is JupyterHub, I don't know if you saw it, but there's a little message in the spawn page. Maybe I could get it if I go to. So this is east. Maybe I could show you quickly. So in the spawn page, okay, this right here. Let's see if I could share that. Okay, so it's the message will disappear in a moment, so that's why I'm saying in chat. But you can see that it gives you this message that you've been assigned Jupyter Lab East / and then Jupyter in my username. And then it says to RCI NRP CPU -4 SDSU.edu. So that last string, the RCI string, that's the node that your server has been assigned to. And then Jupyter Lab East. So since I spawned in using the East URL, this assigns me to Jupyter Lab East, which is its own Kubernetes namespace. And then it created a pod called Jupyter D4D is dash 40 UCSD dash 2E EDU. So if you see this is D4D is dash 40 UCSD dash 2E EDU, that's just my email address. So whenever you're asking for assistance in the matrix chat while you're working on a JupyterHub workflow, it's pretty important to include these kind of details. So um, if you just tell us if you're working in West or East Jupyter Hub, then that's enough for us because that tells us what namespace you're in Jupyter Lab East or Jupyter Lab. Those are the two namespaces that we have our Jupyter Hub. And then if you tell us your email, so if you tell us the email that you use, so if I were to tell support I'm using Jupyter Lab East and my email is d4dias@ucsd.edu, then the admin is able to locate you and your persistent volume claim, and then we could update things for you as needed. So, and then it's also useful, though not all the times necessary, to know what node you're working on. So if you're having some trouble and it's having some issue with the notebook or with Jupyter Hub that you can't understand or that doesn't make sense, and you know which node you're on, then we could check. We could check if that node is undergoing some kind of issue that hasn't been reported, and then we could taint that node so that other people won't use. So it's good to kind of keep an idea of that as if you have it. Um, okay, so I'm going to close um, this east one because I'm not going to use it, and I don't want to keep those resources away from other users. Is the east. Okay. Okay. Okay, I'm gonna just pause again for any any questions that people might have. Okay, seems pretty clear. Then I will continue. Now, what we're going to do today, oh, let me get so I told you to go to this page with the intermediate training. So I am going to download this file so that I could read it easily in my notebook. And then something nice with JupyterHub, if you've never used it, there's this drag and drop feature. So I just download the file and I could drag it to this page, and I could open it up. Okay, you can see. And then you could also position things like this. Here, I'll share the intermediate training link. So, okay. I'm also going to download. Okay, no, this is fine. Okay, so this is what you should have. So I just, with your windows, you could just organize these as you wish. I have, so when you first open Jupyter Hub, you should see this launcher page, which has options for either creating a Jupyter Hub window or creating using VS Code. So that's another common use case for Jupyter Hub and NRP is you could create this yes, I trust. You could start using Jupyter Hub. Uh, I'm sorry, you could start using VS Code through Jupyter Hub. So a lot of people use VS Code is a pretty common editor, and a lot of people use this. One thing to note is that this is not your local VS Code. This is, running on a container on a node, so it won't have all the extensions and things that are in your VS Code. But if you are just a fan of VS Code and you want to use it, that's available to you. And then when we get to Coder, Coder actually does use your own VS Code, so we'll go over how to do that in a little bit. But I'll close this for now. Um, the other thing you can see is that there's options. So you can open a terminal like I have here, you can create a new text file, new markdown file, Python, etc. So I'll close this launcher because I don't really need it. And then the 5 GB of storage. So everything that you see over here, this is under your home folder, where or your persistent storage is. So anything that is in this under this folder is saved. When you save your um, when you save your session and you log out, so I'll log out now just to kind of show you. I'll log out, and I'll sign back in. Anything that is in that home folder will persist. So that, if you close your session or you get disconnected, or what have you, when you start the session again, all of it's available. Um, and you know, so here you can see exactly the same layout that I have. And then also if you were to like close down the server completely, like if you were to uh, stop the server and then come back 2 days later, for example, then the same thing would be saved as long as you save that session. Um, and w things that won't be saved is like if you were to install something in a different location. So if I were to do like sudo updates, install Vim. So here I'm installing Vim as an example. Um, oops, yes. And then you can see that this is under a different folder, right? This is under user share, etc., right? Or so user bin. And this is not the persistent storage. So although I installed Vim here, and I could Vim, oops, Vim test.txt, and I could look at this, or I could create this file. um, it doesn't this won't persist. So when I shut down the server, Vim will not no longer be installed because it wasn't installed under home. So just a clarification for people who are trying to work and understand how storage works. But so this test file, this was saved under the home directory, so it will exist. When I close it, just Vim itself will not. So I'm just going to delete this. Um, Okay. Now we'll start getting into the LLM. So let me just show you, go back to the training script. So NRP offers a number of LLMs. Let me just go to the documentation page. LLM. So here you could get more info about the available LLM models and how to interact with them. I'll share this here in the chat. Um, so there's a number of models, including Quen, Kimi, GLM, etc. And then there's different ways to interface with these. We'll be interfacing using Jupyter AI. So uh, that's why we opened the notebook here. But you could also access them, given your token, you could access them from your desktop or from some kind of other client. Let me just open the Jupyter Notebook page as well, because that one is a little bit easier to view. Mhm. Oops. Okay, this is all the nice format. Um, how about the cells are empty? Okay, let me just go back to this. Um, so yeah, once you have your token, then you could open so you guys could try this now if you want. You could open this curl command with the with your terminal and then use the token that I generated to view the models. So I'll just do that and I'll send the token or I'll send the line with the token in the chat. Um, so if you were to run that in your terminal, you should see I'll share it. You should see this basically, which lists all the models available, and some data about some metadata about the models. Um, the other thing that you could do is you could interact like as a chat interface using Python. So I won't do that now because we're gonna start using the LLM with the Jupyter Hub. Um, but let's go ahead. So we have our API keys, and now we'll go to Jupyter Hub. Um, so can I just get a like a show of hands or is everyone at Jupyter Hub and has a notebook open and similar a server open similar to me? If you don't, please go ahead and send a comment, and then Mohammed or myself can help you kind of get that started. Mm. Okay. So what you should see is if you go over here to this little chat feature, this is for the Jupyter AI. Okay, and Kyle, you don't, oh, okay, yeah, do you have any namespace yet? Or is this no namespaces at all?
None yet. Yeah, and
Okay,
it's won't give me an authorization issue when I go into Jupyter Hub.
I see. Yeah, yeah. So you need to be a member of a namespace in order to access the the NRP Jupyter Hub. Let's see if you can. Okay, so it looks like Mohammed took took care of you. So you should be able to start working in Jupyter Hub soon. Okay, so for others, so this is the Jupyter AI. So this when you click on it, you'll see some examples of questions that you could ask. If you so it will work with the notebook that you have open, and you can ask it a question about it. You can ask it to fix an error in a cell that you have, or there's a number of different tools that are available. But in order to get working with it, we first need to configure it to work with NRP. So so I added this before, but what you guys should do is open this. So in case people didn't see it, we want to go to um, the settings button up here. Click that, and then you want to create the following settings. First, you want to select for completion model. You want to select OpenAI General Interface. That's this one. For model ID, you can put any model that came from this list. So here I have Kimmy. I could also do Gemma 3, for example. Um, I'll just put Gemma 3. But this list that I sent you, sent you in the chat will have all the different IDs available. And then for the API URL, you guys should provide this. This is also in the LLM page on our docs if you guys need to find it, but I sent it in chat. And then the last thing that you want to do is in the open in under API keys, that's where you want to add the token that we used earlier. So let me just grab that from the chat and I will send it again so that people can find it more easily. Oh, it's not a link. It's a URL that you provide the this chat interface, Trevor. So you add that here under the base API URL. Yeah, no problem. And then yeah, the last step was to add your key. So I'll add this one here and I'll save it. Um, so you might have, so since I had an existing key, I had to click save twice. So just ensure that ensure that you see this message API key was updated or saved successfully. And then when you do it, the box will show it will show open AI underscore API underscore key. So you won't actually see the key. Um, but I'll leave this up for a moment just for people to kind of go through and copy the same configuration. That's a good question, David. I forget. I it might not say show a message, but I think what you should see is this field. I think it was blank before, and then after you added your key, you should see open AI underscore API underscore key. Let's see, I could delete this, and then that's currently used by the language embedding model. Okay, I can't delete it because it's in use. But in any case, we could test it. So now that I'm just gonna add that key back again just in case I made a mistake. Okay. So now that we added those items, so OpenAI as a completion model, some model ID, Kimi, the API URL, and then the API key. Let's go ahead and save that. And then we'll go back. And then we could test. So we do what time? Oops, time is it? And here so this is me asking what time it is. So Jovian is the user ID that everyone will have when they're working on with the Jupyter notebook. It's the default username. Um, so here I asked what time it is, and then the LLM responded they don't have access to a real clock. So it's working, and it tells you what you can do to check the time. So um, if you didn't have something configured correctly, if I recall, there would just be some kind of error message. Um, so okay, so if you see the mask dots covering the key, I think you just need to, is there a green check mark still? If there's no green check mark, Trevor, I would just hit save. Yeah, okay, yeah. Save the settings and then come back to chat. So is everyone able to get the Jupyter AI configured to start working? Okay, so this okay. Open AI not found error. For David, do you have this API URL?
Yeah, I do.
Okay, and was your key saved?
Yeah, it turned to the red trash can appeared.
Mhm. What model are you using?
I tried the Gemma 3. Let me try your Kimmy. Uh,
I should note also, while we're using the NRP LLMs, you can also configure this to use if you have your own API key for some other like OpenAI or other LLM service. You can also configure these here, but LLM or NRP provides these, so it's nice use of it.
that got it. I must have done something wrong
Okay, yeah,
somewhere.
maybe the model is just named differently, and yeah,
Yeah,
okay.
thanks.
Um, Okay, so here I will put the cell, and okay, you can see that there is a couple of issues with this. Let's see if I could ask um, the LLM to fix it. Let's try fix. So here I selected the cell, I ran this command fix, and you can see that the cell was provided as input in my prompt, and now Jupyter not is thinking, and it's telling me, okay, there's two problems. It's missing the colon after five, and then it should use range. Um, and I think I could just replace. Yeah, so I could replace it. And now for I and no, that's not what I wanted. This. Yeah. Okay. There we go. So that's yeah, that's how you can use Jupyter, or that's how you can use the NRP LLMs with our Jupyter Hub. Um, and let me just go ahead and go back to the training script. Okay, so I think we'll take our first break here, but before going to the break, I'm going to just pause the recording so that people could ask questions. Recording. Let me clear this message. Oops. Close. Okay. Okay, so continuing on with the tutorial. Welcome back, everyone. I'm just trying to organize these Zoom Zoom windows. Okay. Um, so we're gonna continue on. So we showed you JupyterHub as deployed by NRP. Next, I want to quickly show the other service that we provide, which is Coder. So I will go to Coder, and I'll send this link in a moment. Coder.nrp-nationalist.io. I'll send that to you. So sign in with Authentic, just like you would in any other NRP service. And then you should see this. So Coder is another platform for development, similar to JupyterHub, but there's a couple different options, or a couple different things that you could do with Coder that you can't necessarily do with JupyterHub. probably the most glaring difference is that you could have multiple instances of your coder workspace, different workspaces open. So from Jupyter Hub West, we could launch one server at a time. So you're working from that single server. Oh, actually, one thing that I was going to mention, just for this is for Jupyter Hub. So of course you should close your Jupyter Hub and such when you're no longer using it, as we mentioned about returning resources. But all Jupyter Hubs also have culling enabled, which means that after 6 hours of idle use, so you're not interacting with Jupyter Hub directly, the server will shut down on its own. So just keep that in mind because we have sometimes instances where people are working on something, and then they leave their notebook open, or they have some process running, and they haven't touched the browser in a while, and then in 6 hours it gets shut down and they lose what they were working on. So just keep that in mind that this Jupyter Hub is really meant to be used interactively. If you need to run something that takes extended period of time where you're not directly interacting with it, then you're better off using a Kubernetes type workflow. Um, Also, make sure that you're saving everything periodically as needed for Jupyter Hub so that you don't lose that. Okay, so go back to Coder. So as I was mentioning, I could have multiple Coder instances running at the same time. So I'm just going to start. This is one that I had running before, and then I could create a new workspace while that one's starting. And then here you can see there's an option here to create a new workspace, and then I could pick some kind of so let's pick this general one. And then what you'll see next is a picker kind of page similar to the one that we had when starting the Jupyter Hub server. So I'll give it a name, enter tutorial. Yes. Um, oh, and they even give you nice, let's use their strange little suggested workspace names. And then you could pick options just like you did for JupyterHub, namely the region, number of CPU, number of GPU, the memory you need, if you need a special GPU. You could also specify a node that you wish to work on. So we could keep it as any, but here you could specify if you need to work on a specific node, the node name, the image to load. So yeah, let's go ahead, just do this one. Um, and then FPGAs are also available in Coder. Let's pick two. Oh, this seems fine. Create workspace. Just wait for this one to start up. Okay, while it's starting up, I'm just going to go back to the workspaces page. And then, yeah, now you can see both of them. So this one is starting. I'll just click this one since it's already available. Um, so you can see we have a couple of options here. You could, just like Jupyter Hub, you could work with the terminal. So if you click on terminal, actually, I don't know. Are you guys able to see this terminal window that popped up?
No.
No? Okay, I think it's because I'm just sharing the one Safari screen. Let me try. Oops. Okay. So when I clicked on terminal, this terminal window popped up in another browser window. And then you could also uh, open Jupyter from Coder. So this is another Jupyter lab. This is different from the Jupyter Hub, um, the one that we were working with, the Jupyter Hub West that we were working with a minute ago. So, but similar idea. I'll just close this. There's cursor for, oh, oh no, that's not working. Maybe this is, I'll have to check that. I'm not sure why that's not working. And then there's also VS Code. So, uh, so here we go. So one thing that you'll notice that's also different, unlike Jupyter Hub, where you had access to VS Code, where it loads VS Code editor on the machine that you're working with, where basically it's just a vanilla instance of VS Code. Coder actually works with your local VS Code environment. So when I clicked VS Code, it opens in my on my desktop under VS Code, and here I have access to any plugins, for example, that I've used. But I'm also working with my Coda workspace. So this is yeah, Coder D4D is one main, right? So these are the files in that workspace, and then I could develop here using any tools that I have installed. Go back here, and I will pause here in case there's any questions. Okay, no questions. Um, Let me go back to. Okay, so just so as I mentioned, JupyterHub and Coder are just two services that we provide. Um, they have some similar features, namely being able to work with VS Code or JupyterHub, giving you a terminal to work in, an editor to work in. Um, and they have their different pros and cons depending on what you use. So, for example, Coder allowing multiple workspaces and giving you access to your own VS Code. And then Jupyter Hub is pretty easily accessible by many people, and but you only get this single instance of a server. So I think if there are no questions about Coder, we can continue on with the. Oh, and I don't see the chat, so maybe there are questions.
How reliable this service is?
Um, I mean, so what do you mean by reliable? Like,
Like it's like available like 365 24/7 or like
oh
there's
yeah,
99% availability or something like that.
yeah. It's a persistent service that we provide. So whenever you need it, it's available. Pending any like NRP level disruptions, right? So um, it 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 should become available, or it should be available whenever you need it, unless we're like updating something, for example, and need to take it offline for a little bit. But that's pretty infrequent, and it should have a small impact. Um, yeah, so Coder should have the same calling feature enabled, I think. Is that correct, Mohammed? All pods basically have a timeout feature, but I think Coder might have an idle timeout too. Is that correct?
Yeah, so it has something similar to calling.
Yeah. Okay. So let's go ahead and continue. Um, Now we'll move on to deploying JupyterHub. So let's see. Deploy JupyterHub. Let's make this a little bit bigger. Okay, I think we will run this from the Jupyter notebook. So does everyone still have their Jupyter notebook open? No, it's not a problem. But just like we did in the beginner track, we're going to work with Kubernetes directly through JupyterHub. So we had to do a little bit of setup here. Let me just open that page again. So I'm gonna send this link to everyone because this is how we this has some instructions for setting up your JupyterHub for working with Kubernetes. And we're gonna look at that again. Okay, so go back to my terminal. So I will run these commands and then also send them to you. Oops, got my Okay, so there's this curl command. So if you guys weren't part of the beginner track, what we're doing now is in order to use Kubernetes API using things like kubectl command, you need to actually let me double check real quick. Um, yeah, so we're gonna want the Kubernetes. In order to use Kubernetes API, typically you need access to two tools. One is kubectl, so this is kube control tool, command line tool, and the other one is kubelogin for authentication. So we're installing these right now, and so you could run this to check that you've installed kubectl, and then we will install kubelogin. So to install kubelogin, I'm first installing brew, and then brew install kubelogin. Oh, don't forget to do this step actually before. Let me do that so people don't follow along out of pace. Okay, run that, and then brew install kubelogin. Okay, and how are people doing? Are they following along with these steps? So I have Kubectl installed. Let me and I have kubelogin installed. The next thing that you need to do is to um, get the config file. Um, so okay, let me just open this. Keep clicking the wrong thing, sorry. Okay, config file is here. I'll send it to people. But you can download this config file, and then we're just going to drag and drop it um, into our environment. So one thing to note is since we're kind of using Kubernetes in a kind of a specialized way, we have to make some changes to the like traditional config file. So the thing that you downloaded directly from our documentation should look like this. And you'll notice it'll say something like token cache storage equals disk. And then we just had to make a couple of modifications to use it with JupyterHub. So I already made these modifications and I'll just copy them um, and I'll share them in the chat so that you can add them to your config file. So if you just want to replace the whole arg section with what I'm sharing here, this should work for you. So I will run copy config. Mine is named config2. Yours could be named whatever you want to call it. Oh, and if you're unsure how to edit, you could just double click on the file and then a text editor will open. So in Jupyter. And then to use the config file, we just need to move it into the .cube folder named as config. Then I could test it with a command git nodes. Here two. Okay, this is wrong. Let me see where this. So config 2. Turn off queuing, offline access. Oh, I might be missing a skip. Yeah, sorry, I believe I'm missing one line, which is this skip open browser. Oh, my fault. I sent you the wrong config. Okay, let me delete this. Sorry about that. Should be this one. So that's an example of why this won't work. So the config file that you download from our documentation assumes that you're going to be running locally, and it will open a browser window. But this won't work because this is on some node. So I just sent you the fix, and I'm going to move this config. Yes. Yep, open browser. Okay, great. Okay. So sorry, that was probably a little bit confusing. Just want to make sure are people able to, get kube control, kube login, and the config file set up such that they're able to run uh the git nodes command that I just ran. Okay, so there was probably a mkdir. Try doing mkdir -p // cube. Try doing that before the copy. If you don't have the .cube file or .cube directory, then you'll get that error. So the config file is in our docs, but we had to do a small modification to get it working for JupyterHub. So the link is here. If you go to the docs, download that config file, that could be your starting point, and then you drop it into you drop it into JupyterHub, and then what you should see is something like this storage equals keyring. Yeah. And then you would replace that with the block that I added. So the I sent an arg block in the chat. I'll just send it in. So basically, if you take this block that I added and replace the whole arg section here with that, then you should be set. Okay, so hopefully we're all set. Basically, if you're in the terminal and you can run the kubectl git nodes command, then you're set, and we won't have to do this anymore. And we could continue with the intermediate track training. So I'm going to close this for now. I'm going to go back to the training. Okay. It's better around here. Sorry, I'm just going to download the Just gonna download this one more time too. Sorry, folks, just one moment. I just wanted to download the Jupyter file in case I had the wrong one. Pages, maybe load. Okay. I don't know why the formatting looks so bad on this. Oh, this good? No. Okay, it's fine. I'll go back to the markdown file instead. Okay. Now, so deploying JupyterHub in your in your namespace is managed by a process. It's uses this manager called Helm. So Helm is basically it's a package manager for Kubernetes applications. You could think of it as I don't know, like pip or like or even like a small repo like Git or something like this. But basically there is Kubernetes applications are basically some collection of configuration YAML files, all orchestrated to work together to provide some final product. And some of these recipes exist for common use cases such as JupyterHub. And then users just need to provide a single file that specifies some values that are specific to how they want to run this application themselves in Kubernetes. So there's a Helm chart for JupyterHub. And to get started using Helm, we could start running these commands. So the first, oops, close this a little bit more. Go back to my terminal. So first I'll check if Helm is installed. It's not installed, so I'll brew install it now. So we just ran brew. Well, we just ran brew, so I could do brew install Helm. Sorry, I should send this here. Okay, so it should be good. And now we need to add the JupyterHub repo. So go ahead and run this one. Helm repo add JupyterHub. So this this will essentially make sure that you have access to the JupyterHub Helm chart. And then we can run update to get make sure that everything is up to date. And we could check that we did this properly by running Helm repo list. And you can see, yes, we have JupyterHub available to us. And then you could see the actual Helm chart by going to that URL. Let's see. And then what you need to do is provide, like I said, this configuration file. So it's listed here in the document or in the Markdown or JupyterHub, whichever one you're following. This is what we call the values file. So let's go ahead and copy this, and then I will create a new file, a new text file, and I'll paste all this here. I'll rename it. What do we want to call it? Okay, JupyterHub, JupyterHub dash config.yaml. Maybe this dot text. Okay. And now, so this is what I'm was mentioning when I said that as a user when working with Helm, you just need to specify what's called a values file, which is just a config file with specific info regarding how you want to configure your Jupyter Hub deployment. So that's what this is. So here, let's see, we could go through. So let me also go to the documentation and share this with you. Jupyter. There we go. So we have a guide for people who want to deploy Jupyter Hub in their own namespace in our documentation page already. And from that guide, you can also view a template for the values file, which is this. Today, so one of the things that you'll need to do if you were to do this in your own namespace in the future is you'll need to create open an basically a CI logon CI logon service account for this. So just like users use CI logon to authenticate themselves when logging into the cluster, if you want Jupyter Hub to be able to interact with the cluster and create pods and stuff on its own, then you'll need to provide you'll need to provide access by giving a CI logon credentials. So there's a little bit of instructions about how to do this. So registering a CI logon application. I just to stress right now, we're not going to do that. But in the future, when you need to create your own deployment, this is what you would do. This would be the first step because it could take, a few days to a few weeks for CI logon to approve this, and it's not something that NRP ourselves have any power of speeding up or anything like that. So you'll need to make sure you do this ahead of time. There you can register the application, including what URL you plan to use with the application. And then CI logon will reply to you that it's been created. And once that's the case, then you could go back to the values file, and then you could add your ID and secret for that application, and it will be fully authenticated just like a user would be. So that's what these lines are doing. In our example, we're kind of not doing that here. We're doing a simple authentication just for the purposes of the training. So you wouldn't want to copy this moving forward. Please use what's in the docs, but this is how we're doing in the training. You can see there's an authenticator here. And then we could go through the different sections of this values file if you like. But for right now, I will just highlight some of the important bits. So hub, this will be the main process, which is responsible for um, managing the creation and deletion of your JupyterHub pods when you get it running. When you get down to this block called single user, this is important for defining how each JupyterHub instance will look for a single user who's logging in. So everyone will get this ID 0, and then everyone will load the same in this configuration. It may be different in the docs, but in this configuration, everyone will load the same image, which is the SciPy notebook, and then it will each pod will be requesting 3 CPU and 10 gigs of memory, and then it will default make a PVC of 5 gigabytes, which is read write once because it's rook ceph block, and it will be given a name according to the username. So that's what this is all saying here. This would be very similar to what you see when you create your own, and this is how, like, if you're managing a classroom or a group, this is how you set controls in your own namespace for users. So maybe you want everyone in the classroom to load a specific image that you have configured, and you want them all to use some specific type of resources to keep everything fair. That's how you would do this. And then a requirement, just so this isn't on by default, but it is required by our NRP policies to enable culling. So this is just where you set this timeout limit that if they're inactive for 6 hours, then we shut down the server automatically. Okay. Um, so as you can see, this isn't like this isn't super detailed. Like you might imagine something that's going to create a JupyterHub instance in your namespace might have a whole lot of parameters that might need to be set. This is all done on the back end, and you just need to provide these kind of like front-facing parameters for how you want things configured. Okay, so everyone should have this config file. Let's go back to the training script. Part of the config, so you'll see there's a in the proxy here. In the proxy, you'll need to provide a token. So when we say token here, what we mean is you just need this random value essentially. So if you just go back to the terminal, enter this command, you shouldn't use the same token that's printed here on my screen. You should use your own. But you run this command, and then it will spit out a value, and you can replace it in here. And then I think, let's see, I think that this is all that we need to do. Before deploying it. Okay, we'll go back to the terminal. Go here. So we're gonna practice deploying this in our namespace. So for the purpose of the tutorial, if you already have a namespace using JupyterHub or that already has JupyterHub deployed, this won't work. So make sure you use it in a namespace that doesn't have JupyterHub or have used JupyterHub or is using JupyterHub right now. Oops. So I'll just call it JHub BDS. Okay. So here I'm just copying this line from instructions, which says to install this JupyterHub deployment using Helm. If it fails, it will clean up anything that was created on its own. I just provide a namespace, name, a version number, which values to use. So we just created this JupyterHub-config.yaml. And then it has a 10-minute wait before it calls it quits in case it cannot install it on its own. Let's see. Pre-install warning 9. Users are not allowed to deploy daemon sets. Why is this? Let's see if anything was created. No resources. Skip a step. Oh, the generate. No, I did secret token. Sorry, has anybody run the Helm upgrade command yet? Are they getting the same message as me, or are they seeing something different? Check my namespace. Maybe I don't have information. Oh, it might be because I don't have this information. Uh, but this stuff should be efficient. I didn't get that message. Hey, Mohammed, did you run into this?
Not really, no. Let me see. Yeah, so the pre-puller, is it disabled? It should be. Is this the markdown or the notebook?
This is from the markdown file.
So in the Helm, sorry, I'm looking. In the values for the Helm, is there a pre-puller?
I don't see so. What section?
So sorry about that. The pre-puller should be explicitly disabled.
Oh, okay. Is that in the?
So let me see. It could be a branches issue. Though let me see. So the markdown notebook on the main branch has it.
Okay, okay. That's probably why I was taking from the pages branch. Mm. Oh, this is too far ahead, I think. JupyterHub. Oh no, this is it. Okay. So this just has everything already. Okay. Sorry, folks, if you not sure where people are, where people are getting um their config from, but I will add this. Oh, it's too long, of course. So I will just send you the link to it so that you could take it from into everyone. Okay. If you guys aren't already using this, so the problem was that I was using a different branch where the code was a little bit out of date. The config file was a little bit out of date. So I switched to the main branch, and then I'm using the JupyterHub config.yaml in this branch, which I just sent in the chat. So let me go back to that. Let me grab my random key. See, it's the same one. Proxy. Save. Let's see. Okay, so let's see if this works now. And then also for Trevor, like I'm looking at I'm looking at your message. It looks like the namespace just wasn't set properly. So maybe there's a typo, but you can see that it says in namespace and then it's empty quotes. So um and yeah, you can see that otherwise it did try to install your Jupyter Hub, but it was just not pointing to a correct namespace. Mm. Okay, while I'm waiting for mine to run, how are other people doing? Are you running into any issues, or are we all just waiting for this to load up? Okay, let's see. Okay, so you guys should see something like what I just got. Um, yeah, for release name, you could provide your own release name as you want. So I guess you could version control your releases in that namespace if you like. Um, let's see when I run get pods in my namespace. Yeah, you'll see that I have two pods created. One is the hub and one is proxy. And then, once I start using this to create notebooks, another pod will be created for the actual single user notebook. So everyone should be kind of at this stage right now. Let me also go back here and get the updated file from Git so that I have this to work with. Okay, let's see where. Okay, great. So we have things running. We have the oh, sorry, I see a question. Just 1 second. Yeah, so you might need to set your context, Paul. Let me just send this to you real quick. Paul, you might need to run this. If that's not if that didn't help, let us know, but that could be the problem. Because it looks like it's pointing to the correct namespace, but it doesn't know what cluster you're trying to interact with. Okay, I'm gonna go back to the tutorial. Okay, so we have JupyterHub deployed. You can see it running in our namespace, but we don't really have a way to interact with it, right? So most people interact with JupyterHub by entering the URL to reach the notebook or the server and then begin coding. So what you want to do, or what we'll need to do, is configure ingress for this. So we will, let's see, is it in our file yet? Ingress. No, it's not part of the file. So what we want to do is take this block from the tutorial write-up and add it as a new block in our YAML, in our values YAML. The ingress enable true proxy, my Jupyter name. So what did I call it? JHubDD is, I think, right? Yes. Okay, should be good. Okay, now I want to upgrade. So to upgrade, the same thing, except we do not need the install flag. So to make it clear, what I'm doing right now is my config file had no way to talk to the outside world, so we created an ingress. So we added that as a new block in our values file. I'm sorry, my Jupyter Hub had no way to talk to the outside world. So we created an ingress and we added that as a block in our values file, this Jupyter Hub-config.yaml. You can see I added ingress here and I provided it a name, or I changed some of the text from the tutorial notes so that will work. So namely, the release name that we used needs to be changed on the host lines. And then back at my terminal, since I made this change to my local file, I need to propagate it to my running Jupyter Hub. And to do that, I use the Helm upgrade command. And you can see now it provides me two URLs. So if I click on one of these URLs, it should take me to Jupyter Hub, right? So, and then I could run crypto get pods again just to see. You can see that since I made this change, the hub pod was updated. So it's only 87 seconds old now. And it's running this new, let's see. Oh, so we provided some username and passwords. So admin and training123. Let's do that. Admin training123. Sign in. Don't remember. And there. Now we have our picker again, like we've seen. So I'm going to go ahead and start a new server. And it's going to look very familiar to what we've seen in the previous sessions. You can see that I created a new PVC and I successfully attached that to my pod. The server is just starting up now. There, perfect. So now I have this new notebook. So importantly, so just like before we were using JupyterHub-west.nrp/nautilus.io. This is no longer running in the Jupyter Lab namespace. Now it's running in my own namespace. So when I go back to Jupyter Hub West, and I check the pods in my namespace, you can see I have a hub pod, a proxy pod, and then a Jupyter pod as well. And then my username on this pod is admin, so that's why you see this here. And so I'll just, so this command should not work for you guys, but I'll just show you. If I were to look in the other namespace, Jupyter Lab, you can see that these are the pods running by other people in our Jupyter Hub West namespace, and one of them is mine, the one that we're looking at right now. So this is the one that's showing here. And just trying to stress that these are now in different namespaces and different deployments of Jupyter Hub. Okay, so this is the main items that I wanted to show you. In the tutorial, there's some advanced steps, namely how to change some items in the config, which you might need as an instructor or as a lab group PI. In the next section, you could see how to change image profiles. So in your config file, we have we have this section right here that shows all the different profiles and a path to the image that you want to use. So here's how you would add those, and you could change them for your own images that you create, for example, to create limits per user server. You would go to the single user section that we were looking at earlier. And here you could see you could set a limit on the CPU, the memory. You could create, so here this shows also here this is adding a selection option if you want. It could be a small, medium, or large option if they want 4 CPU, 8 gigs of RAM, or large 8 CPU, 16 gigabyte RAM, etc. So that you could give your users different profiles to work with if they don't want to use uh, the one that you configure explicitly. Um, and I think that's it. So if and the last thing that I'll just mention, if you need to shut down your Jupyter Hub for whatever reason, maybe you had some problem and you don't want to leave it open for anyone to access, you would just run the Helm uninstall. So Helm uninstall. I'm not going to do it now just because in case there's questions and I need to show you what to do. I don't want to tear this down, but when we're done with this, I'll run Helm uninstall jhub ddias -n ddias, and that will close down the deployment of Jupyter Hub in my namespace. So I think now I will pause the recording